Consider two seemingly unrelated half cells. We have the reduction of copper 2 plus to copper, and we have the reduction of silver 1 plus to silver. Let's draw the cell. We're going to label the cathode and the anode along with the respective potentials, and we're going to calculate the overall cell potential. So we need to figure out which one of these is which of the two reactions listed is the oxidation, which is going to be the reduction. When you look at the standard reduction potential table, the best reducing agent is always found in the top right, so this is going to be lithium. The best oxidizing agent is at the bottom left. All right, so in this case, this is molecular fluorine. I say that because the standard reduction potential table was often written just as one long table. In this version of the data booklet, it's been split. So the best reducing agent is going to be oxidized, and our two half reactions that we're looking at I've highlighted here with the arrows. The strongest oxidizing agent is always going to react with the strongest reducing agent in any given redox scenario. So what this means is that copper is going to be oxidized and silver 1 plus is going to be reduced, giving us the anode and cathode respectively. All right, so if copper is going to be oxidized, that means I'm going to have to reverse the equation here. So I'm going to have to reverse the cell potential. All right, when I go to actually assemble the cell, all right, I'm going to put copper and silver electrodes. I'm going to put copper and silver appropriate ionic solutions. I'm going to make sure I label a salt bridge. Here I'm going to label copper as the anode because we've seen that this is going to be where the oxidation occurs. Silver half cell will be the cathode, negative and positive cell potentials respectively. All right, I'm going to want to label the half reactions that occur at each of the half cells just for completeness. One way we often summarize this is the half cell that has the more negative cell potential. Okay, so in this case, 0.34 was more negative than 0.8. That's going to be the cell that acts as the reducing agent. So that's the one that will be oxidized. All right, I can go back here and label the electron flow. So as I just said, copper is oxidized. It's going to provide the electrons to reduce silver 1 plus to metallic silver. I can compute the electromotive force or standard cell potential of this scenario. All right, I'm going to add the half cell potentials together for the oxidation reduction. This gives me 0.46 volts. So as drawn, we'll come later to see that this would be a spontaneous reaction.